Okay, let's see. What did we write so far? So the idea is we take in a string that looks something like that with no extra white space, and then we call process expression on it. We're hoping for something like this. Actually, didn't we? What was the number we were expecting to get out of this? 63 if I changed that to a 1. Because I couldn't multiply by 7. It was too big of a number. Okay, so as we're walking through this, we start off with kernum. Amish, you're here.
Yeah, we finished early.
We thought it was first frost. Did you do your homework?
Yes.
Did you get working?
I got it done at 2 o'clock in the morning, but I got it working.
Oh, that's good.
It was a pain.
Was it?
Yeah.
It should have been easy. Oh, wait a minute. Maybe I'm showing you the easy way of doing it today.
Probably.
Can somebody get the lights? All right, so what we're doing here is we're processing the expression is we need to build up our numbers, right? So how do we build up a number? If our thing looks like this, as soon as we hit an operator, that means we're at the end of a number, right? And when we hit the end of the string, we know that we have one more number built up. So as of right now, what does our code do? Our code goes through and it prints out all the numbers. So for right now, if I run this, it prints out a 123, a 5, a 2, a 1, and a 2. Is the theory. Okay, 123, 5, 2, 1, 2. So it goes through and picks out all of our numbers. Make sense? Now, so that's what process expression currently does. It goes through our input string, every character in it. If we're looking at an operator, then what it does is it prints out the number we just read in and then zeroes out our number. Now we're going to want to do more than that. Okay? Because if we're looking at an operator, what comes next? Another number, right? So what comes next is another number. So once I read in the 5, so once I hit my next operator, let's say, then I want to actually do the math, 123 plus 5, correct? All right, so if I just hit an operator, now I need to ask a question. I'm going to create another variable here. Let's say char cur op. We're going to start this guy off at a question mark. We have no current operator to begin with. Okay? So now we're going to ask the question. If cur op is equivalent to the question mark, so the first time through, what do we want to do? We want to capture the operator that we just read in. Cur op is equal to s dot char add I. So we'll go ahead and read in that operator. All right. Now that means that if we're walking through this string, we just read in our 123. That's stored up inside kernum, and then we just ran into the plus sign. Now, since we just ran into this plus sign, we don't actually do any math yet. Why? Because it's the very first operator we ran into. We still need to read in another number. So we're going to go ahead and store that plus sign. As opposed to when we run into this minus sign, we have already read in an operator. Therefore, we know we need to do some math. Does that make sense? All right. So I'm going to have a integer called answer. I'm going to start that guy off at 0. Okay? Now, if I just ran into a question mark, that means that kernum as a string currently holds 123. Correct? And I need to turn that into a number and store it inside of answer. Do we know how to turn a string into a number easily? We know %? Okay. So then what we'll do is we'll store the kern op. So in our example here, we'll store the plus sign. Then we'll say answer is equal to integer dot parse int kernum. So we will put the number, by this example, 123 as an integer into answer. All right? And then we'll zero out kernum. Actually, kernum is going to get zeroed out either way here. Else, If curop is not a question mark, that means I've run into a curop before. Okay, so if we hit the minus sign, that means curnum currently holds a 5 as an int. Answer currently holds a 123 as an int. And we need an curop currently holds a plus sign. So we need to take 123 and add it to 5. All right. So what I'm going to do is I'm going to write another little function here. Static int do math. What math are we going to do? We're going to have the operator we're going to do. Int num1, int num2. If op is equivalent to a plus sign, return num1 plus num2. Else if op is equivalent to a minus sign, return num1 minus num2. Else if it's a multiplication, return them multiplied by each other. Else must be division, return num1 divided by num2. That makes sense? So I created a little method that we can call, passing in an operator and two numbers, and it will perform that mathematical operation on those two numbers. So again, what we should be gaining from this is this idea of patterns, where every single time we need to do something, we need to take little baby steps. So instead of solving this giant problem of parsing this string, I'm going to solve the problem of applying a single operator to two numbers. Does that make sense? So now I solved that problem, and now I have a working widget. It's as if I went to Home Depot and bought a tool that already works. So now, and would you agree that this guy is not an overly complicated method? Just a bunch of if statements, right? If operator is one thing, do one thing. If it's another thing, do another thing, so on and so forth. Okay? And ultimately, it's going to return an int. So inside this else, so here, let me give some comments inside these ifs. The first if says if curop is the question mark, then I have just collected my first number and ran into the first op. That's what happens if I'm in this if statement. If I'm in this else, I already have a number in answer and need and read in an op, a new op. So I need to do the math for curop, answer, and the number in curnum, storing the result back in answer. That make sense? So how do I do math? Well, I use my function I just wrote, do math. I need to pass it an operator, that is the operator that's inside curop. I need to pass it my first number, which is the number that's inside of answer, and then I need to pass it my second number, which is the integer version of whatever is currently in curnum. So I'm going to say answer is equal to driver dot do math curop answer and integer dot parseInt curnum. So that will do that math and store the result inside of answer. So the very first time through, I'm going to be calling do math with a plus sign as the first parameter, the number 123, which is currently stored in answer, as my second parameter, and then the integer version of 5, which is the string stored in kernum. And what should I get out of that? This should boil down to the integer 128, and I'm going to store the answer back inside my integer called answer, overwriting the 123 that used to be in there. Okay? Then I'll go ahead and store my current operator. Now the reality is we're storing an operator in either of these cases, aren't we? So I could probably just put that out here. So if this is the first operator I've run into, just store the current number that I've read inside of answer. If it's not the first operator I've run into, let's do the math and store it inside of answer. Regardless of which of those two steps we do, we're going to overwrite curop. So either overwrite the question mark or overwrite the operator that we just applied, because we already did the math with the old operator, with our brand new operator. And then zero out kernum because we're going to be reading in another number. That make sense? So that's all the stuff we do inside of this if. So this if says, if I'm looking at an operator, we wrote this last time, if operator, or rather is operator. Is operator returns true if I'm looking at a plus sign, a minus sign, a multiplication sign, or a division sign. It returns true under those circumstances or false otherwise. So that's our convenience method for detecting whether a particular character that we're currently reading as we're walking through our string is an operator. All right, so this loop goes through our entire string. At each character we say, am I looking at an operator? If I'm looking at an operator, we do all this crap we just wrote. Otherwise, I must be in the middle of a number, so continue to build that number. Kernum equals kernum concatenated with s.char at I. All right, at the very end, I still have a number inside of kernumber, right? I've collected it. If we're following this string up here, I read in 123 in the answer, then I overwrote the question mark with the plus sign, then I read in 5 with kernum, stored the result of that math as 128, then I read in the next operator, then I read in the 2 as kernum, took 128 minus 2 is 126, then I read the next operator, then I read in the 1, then I read in the divide sign, but when I read in the divide sign, I did the math. So I have, 126 times 1 is 126. Then I read in the divide sign. Now I read in my final number, 2, kernum. Now, notice I did not hit another operator. I actually hit the end of the string. So as of right now, I have one more bit of math to do, correct? Because I still have an operator stuck in curop. So I need to ask, so at this point, I have one last number stuck inside kernum, and I need to do the correct thing with it. So one of two things is true. If curop is still a question mark, which it would be if my input was this, a situation where I never ran into an operator. In that case, I would have built up kernum, built up kernum, built up kernum, hit the end of the string. So if curop is still a question mark, then I just want to set answer equal to the integer version of kernum. Else, I want to set answer equal to doing the math for whatever curop is, passing it the current version of answer, and passing it the integer version of whatever's in kernum, and have it do that math. Ultimately, I'll return answer. That make sense? So, right now, what does main say to do? All programs begin and end with main. I have a string, S. This guy should produce, what did I say, 63? Oh, what did I do there? I have more strange. Seems like Eclipse is acting very funny here. Let me close it and reopen it. I did. Oh, it's possible I still have something else commented out, because I had leftover comments. Process expression. This looks fine. Why isn't it running?
See that banner that's on the right side?
Which?
The very, very bottom of that one right there, hit that. I'll try to run it.
Oh, it is running. It's running just fine.
Yeah.
And I'm never actually printing out my answer. This guy returns an int. What am I doing with it? I'm doing nothing with it. Always testing you. There we go. There's our 63. And let's see what it would have been if we left that 7 in there. 441. What if we 123 plus 5? This is a 128. What if we just do 123? Gives us a 123. 123 divided by 2. Just a 61. Make sense? Okay. So questions about that? I'm not showing you.
There's always a video.
The else statement's the same thing as the one was above. So at the end of the whole thing, I know I have an extra number stuck inside the current op. If it was the only number I read in, just set answer equal to it. If it's not the only number I read in, which means I still have an outstanding operator, perform the math associated with the operator. It's like opening up a Christmas present. Do you guys grind your own coffee on the
I don't drink coffee.
on the Amish settlement?
I don't drink coffee.
You don't? Neither does my wife. That's just messed up. It seems like that's borderline grounds for divorce. Who in here does not drink coffee? Oh my gosh.
I like the taste, I just don't like the
So why not
drink
drink it?
coffee.
You like the taste, you just don't like the act of getting it. Or it's not part of your routine.
Like,
Like what's
I like coffee flavored other things.
okay? So you're like
But-
you'll eat a coffee ice cream and stuff like
yes,
that.
I like that. I just
You don't want to drink a hot cup of coffee.
No.
It's like that's not your thing.
No.
You like coffee flavor.
Yes.
Do you like hot chocolate?
Yes.
Who doesn't like a hot chocolate?
I was just wondering.
Actually, hold on. Isn't there something I made fun of you last year, Trista? Or something you don't like? That could be literally anything.
Something I don't like.
Isn't there something that you don't like
Food
that?
item?
I think so. Something you don't like that like is weird. Like everybody else seems to like it.
I like pretty much everything except for like onions and avocados.
Everybody likes avocado.
Wow.
I get avocado is one of those.
It's the weird texture
things.
of it, and it doesn't have much flavor.
Same thing with onions. Like there's plenty of people that don't like onions. I mean that's like common. I don't like that thing. Yeah, I don't know. Somebody didn't like something.
Someone didn't like chocolate.
Who was that?
Who was that?
Who doesn't like
I don't know what
chocolate?
you're talking
Okay, another next question. Who doesn't like chocolate in here?
Now they're not gonna admit it.
Yeah, because they'll instantly fail the class if you don't like chocolate. I mean, you don't have to be a chocoholic, but I mean, like if somebody gave you a free piece of chocolate and you weren't like on a diet, like I won't eat chocolate because I don't eat carbs. That doesn't mean I don't like chocolate. I love chocolate. It's totally good. You give me like a whole bag of Halloween candy. If the spirit is willing, I can do some damage. So, man,
Pretty
there was.
sure that's what it was.
You're like prohibited from going out on Halloween.
One of my friends doesn't like chocolate. I don't remember.
There was a lot of people who doesn't drink coffee again. Why? Okay, why don't you drink coffee? Do you like the taste of coffee? Did you ever drink coffee and just don't have an acquired taste? You've literally never tasted it.
I've had coffee.
You just don't like it. You?
I've had it, and I don't know, I'm not a coffee drinker. I don't really need it. I feel better, I guess. I feel better, like healthier if I don't drink it. I don't know.
Anybody have like a valid reason for not drinking coffee? Like, doesn't it concern you that like such a high percentage of the population drink coffee, and like you don't?
Not really.
I feel
You
better
don't fit
about
in.
it then.
Have you
No,
ever
no.
had coffee?
Now, well, yeah, that's it. I mean, if you've ever had like a really good cup of coffee, geez. No, I mean, I can agree with you with the caffeine side of things. You know, if you're going to drink a caffeinated coffee, then maybe like one or something like that. Otherwise you start getting the shakes and stuff. I just like coffee. I mean, this is decaf. So today I've had one caffeinated cup and 6 decaf cups. This was actually part of my workout. I went to the club this morning to work out. And I had 2 cups of coffee before my workout, and I had another 3 on premise decaf after my workout, and then this is the 4th. Except this one I put cream in. This is the post-workout dessert coffee. Oh, man, I can't even fathom life without coffee.
My husband just bought the new Keurig machine.
The Vita,
Yeah, well, the
what is it called?
I can't remember.
You know what I'm talking about. It has like a
Yeah.
new kind of cup. It's like a new kind
They
of.
always have a new kind of cup.
It's like stupid, like proprietary technology.
Exactly.
The Keurig K cups.
But they have, it's like a mocha machine and
Yeah.
and a latte machine and it
Mhm.
foams and everything.
Yeah, I did my. See, I'm. If you haven't gathered yet, I am quite a coffee drinker. So I have a pretty decent setup at my house for coffee. We're not dealing with like a Mr. Coffee pot. If you've ever been into Starbucks and you've seen like their giant machine that has the hopper with all the beans in it, it grinds them, and yeah, I have that in my. This is like a $5,000 coffee maker. But if you think about how much, actually, I don't think it was. This one was maybe south of 4,000, but whatever. Like if you think about how much people spend at Starbucks, I've had that coffee maker for at least 6 years, 7 years. I think I've gotten my money's
You
worth.
drink a lot.
I mean, I probably produce a gallon of coffee out of that a day. I got backup coffee. Like I have the hopper of beans. That's like the go-to normal grind your coffee beans. And then I have additional bags of already ground coffee that I can run through it. If I want like I have this not Starbucks, I have Dunkin' Donuts blueberry flavored coffee. It doesn't sound like it'd be that good. It's really good. It's blueberry muffin. Blueberry muffin. Same thing, kind of, sort of. And it does. It kind of has that hint of blueberry muffin, like you're drinking a liquid blueberry muffin. I put a little hazelnut syrup in it, sugar-free. I don't even understand. Okay. Have I shown you index of? Tell me what you know.
I don't think so.
All right. So let's learn about some other things that'll make this easy. Easier. Easy. Yeah, easy. I mean, it's already easy.
I just had issues with one piece of code that was in the wrong spot.
Yeah.
And then all the operators were working on the wrong numbers.
Well, let's start with this. So I'm going to compress most of these things. So forget about the fact. Delete this. Forget about the fact that we wrote these two methods up here. What does isOperator do? It's a tool that we went to Home Depot and bought. We pass it a character, and it returns true if the character we passed it is an operator and false otherwise. That's what this tool does. Who cares about the details? We already wrote them, now we don't have to think about them. Make sense? So we created for ourselves a little tool. And when you're writing your solutions to your homework and you're writing programs moving forward, think about doing things like this. This is the baby step approach. We needed a little tool for detecting an operator. That doesn't mean we couldn't have put that code inside of here. The point is that it made this code cleaner by putting that little widget, that little tool outside of it and calling it when we needed it. That make sense? This allows us to break our more complex sounding problems into little tiny pieces. One of the tools we need to solve this problem is to be able to identify operators. Another tool that we need to solve this problem is if I already have an operator and I have two numbers, do the correct math on those numbers based on the operator that you have. Right? So I wrote that little tool. And who cares about the details in here? I mean, it looks like a decent amount of code, but it's all trivial code, right? If it's a plus sign, do addition. If it's minus sign, do subtraction, so on and so forth. Okay? So that's what that tool does. So now I have two Home Depot tools that know how to do their job, and I don't have to worry about it. I can just call them. So as long as I know how to call this method, and as long as I know how to call this method, I'm good to go. This method, class method or instance method? Class method, how do you know? Static. This method, class method or instance method? Class, how do you know? Static. Okay, these are the method definitions. How do I call class methods? Let's go with Trista. See if she still gets it backwards. How do I call a class method?
Using the name of the class in which it was defined.
Using the name of the class in which it was defined.
Yeah, it was a bad day.
You have a lot of bad days.
Yeah.
Okay, so
Tell me about it.
name of the class is driver, right? So we call that method by saying driver.isOperator or driver.doMath. Okay, and passing it the correct parameter. So isOperator, I need to pass it a char. DoMath, I need to pass it a char and 2 ints in order for it to do its job. Okay, now we have our bigger problem to solve, the process expression. And what does this guy largely do? This guy is largely walking through a string. That's our go-to move for walking through every character of a string, that for loop. Again, patterns. We've solved several problems, all dealing with walking through strings, and every one of them has that loop in it, right? I'm even using the same counting variable, I. If you if you Google Java programs or something like that on Google, you look at other people's source code, you'll see that counting variables they use for their loops are almost always IJK. That's like the de facto standard for throwaway variables. Nobody says you couldn't have used Z as your counting variable, but if you're copying other people's code and you want to stay consistent, that's what they're going to be using. Actually had a grad student the other day asked, and I mean this is near a quote. I gave them they're doing similar stuff, but they're in a master's of IT, not a computer science So not all of them have computer science backgrounds. So this is kind of their first programming class as well. So this guy comes up to me. He's like, are we allowed to use arrays? So in that class, we haven't dealt with arrays yet. It's an 8-week course. They're only in week 2. So it's like a compressed type thing. And like I do in here, you're only allowed to solve problems in terms of the things you already know how to do. That makes it harder and gives me joy. So in any case, he comes up and says, can I use arrays? I said, no, we haven't talked about arrays yet. He said, oh, because one of the answers I found on Google uses arrays. I just wanted to know if I could use it. At least he's honest. I really think it's a cultural thing. I mean, the point is once you get out in the industry and you're writing this stuff professionally, you find a solution to the exact problem you're trying to solve on Google, use it. As long as you understand it. That way, if you have to modify it or something, you can. But, I mean, isn't that, how many of you would actually say that to me? I mean, you might do it. I mean, I think every one of you is unethical. So we're starting with a real low bar. But how many of you would actually tell your teacher, like, look, I found a good answer on Google, but it kind of uses some stuff that we haven't talked about. Is it cool if I turn that in? But this is the same class that brought me Portillo's from Chicago. Special delivery for class. Portillo's is so good. Are the Amish allowed to eat at Portillo's? You've been to Portillo's, right? Your dad probably loves Portillo's.
Yeah, he did.
Man, your dad's a big dude like me. We love Portillo's.
He likes the ribs.
I think I actually met her dad before I met her. I didn't know it was her dad. We're at Solly's all the time eating butter burgers and stuff with butter all over it. So good. Yeah. He's a nice guy. Way nicer than she is. She could be mean. That's as if she like stares through your soul. Like she's got that mean look, kind of like Trista.
I stared through your soul.
Well, no, it's different. She has a different approach to the mean look. You just look angry.
It's just my face. It really is. It's just my face.
You know they have operations for that now?
What?
Expensive.
Go to the doctor. I want an unangry face.
Make me happy.
See, I have this jovial demeanor. I'm like a beardless Santa Claus. What? There's a bunch of stuff that I say that are part of my normal repertoire that other people would never say. I have a common, yeah. Much of which could not be recorded in a classroom. Okay, so let's redo a couple of these things using some new tools. And I would encourage you to pay attention because there's a high % chance that I'm going to give you a quiz during class today involving something we're about to talk about. Everybody should get engaged. Well, like not really engaged. Gotta make sure I'm clear with some of these people. All right, so we have a method called index of in the string class. So this is an instance method of the string class. Index of returns an integer, its name is index of, and it takes a char as a parameter. There's also a second version of index of that returns an int named index of, but takes a string as a parameter. I don't remember if we talked about this or not, but what's it called when you have two methods with the same name? Polymorphism. Did we talk about it in here? Or you just know that from some other class? Okay. You don't know for sure. I've actually, over the years, I've gotten pretty good at not writing code in another language in the same class.
Like alien?
Well, no. Like in a given week, I teach 4 different programming languages. So I've gotten pretty good at like not writing scheme in here or Objective-C in here or I guess, JavaScript or PHP in here.
Comes to 250. Take out a piece of paper.
It was ready to ski.
Mutable arrays and
See, I get very confused. Actually, where it's worse is like this semester where I'm teaching the grad course and this class, which are covering the same material, but at different paces. So grad course is only 8 classes. So they've kind of almost caught up with you now, but they didn't start till the second 8 weeks of the semester. But each class is 4 hours long. But kind of remembering what I did in one versus the other. I'm too old for this crap.
you ever done it before to teach some other programming language?
Years ago, I would like think I was in the wrong class. I kind of have a funny habit now,
Like
sometimes
once you
asking
came
what
into-
class am I in. That used to be a true question.
I think once you came into architecture class and like started talking about some programming stuff, and then you realized.
Oh, I was in the wrong class, right?
Yeah.
It's difficult. What was it talking about? Oh, polymorphism. So we have 2 separate methods here. Index of. Both have the same name, both have the same return type, both are instance methods inside the string class, but one takes a char as a parameter, the other one takes a string as a parameter. Now, more importantly, what do these guys do? They return the index of the first occurrence. I spelled that right. That was a good one. First occurrence of C or S. Let's just say that the given parameter in the calling string. What do I mean by calling string? Go ahead.
The instance that you're calling that instance method with.
Yeah, the instance of the string class that I'm calling this instance method with. Okay, so this guy will return the index of the first occurrence of the C or S, the parameter, inside the calling string. And here's the most important part of this line. This is the problem-solving part of this. Hint, hint. Or a -1 if it is not found. Hint, hint. That's probably the power in index of, is the fact that it will give you a -1 if it does not find what you're looking for. Okay? Questions about that? So, for example, if I have a string named S that holds hello, let's say, s.index of an H would give me a 0. Because H is at index 0 in the string S. And E would give me a 1. Make sense? And L would give me a 2 because it returns the index of the first occurrence of a character in a string. So even though L occurs twice, it's gonna give me the 1 because that's the bucket, that's the position. I'm sorry, it's gonna give me the 2 because that's the position that L first occurs in the string. This is bucket 0, this is bucket 1, this is bucket 2. Make sense? If I pass in an O, 0, 1, 2, 3, 4, it's going to give me a 4 because that's the first occurrence of O. Finally, if I pass in a Z, or question mark, or anything else that's not found in there, this will boil down to a -1. That make sense? So again, index of is an instance method of the string class. Here's what the method definitions look like. This is an example of polymorphism. Doesn't really matter if you, I mean, I want you to remember it because it's kind of an important object-oriented word, but all polymorphism means is you have two methods with the same name that take a different number and or type of parameters. So this would be an example where they take a different type of parameter. One takes a char, one takes a string. Okay? So how do I call these methods? They're instance methods, right? How do you know this is an instance method if this is the method definition? No static. How do you call instance methods? Using an instance of the class in which the method was defined. So everything that's on this slide right here should tell you exactly how to call this method and what the method returns under different circumstances. Are there any questions about that? Ask them now because I'm about to give you a quiz that's going to force you to use this before you've ever seen it work in real life. I've shown you examples of how it works, but this would be equivalent to you looking something up in the Java documentation, seeing everything you need to know about it, how it works, well, what it does, how it works, how to call it. And now I'm going to ask you to apply it to a simple problem. Go ahead.
How do you make an instance of it?
It's a string class. You don't make an instance of index of. You say s dot. So here's, I'm creating a string s equals hello, and then I can call index of on that string, s dot index of. Make sense? Yeah, so this is not a class. This is a new method that already lives inside of a class we're used to working with. So this is a method of, this is an instance method of the string class. Other questions? Okay, everybody take out a piece of paper. Rewrite the is operator method here using index of. So you have a new tool. You just went to Home Depot. You came home with this index of tool that you now know how to work with. And here I'll even give you a quick little string s is equal to hello s dot index of h will produce a 0. S dot index of L will produce a 2. S dot index of Z will produce a -1. So there's some examples of calling it if in fact your string's name was named S and it contained hello. Okay? So rewrite is operator so that it works exactly like it works now. That is, it takes a char as a parameter and returns true if that character is an operator or false otherwise. But write it using index of. And I'll give you 5 minutes. This is kind of like one of those little puzzle iPhone games. Figure out how to use this new tool to solve a problem. one more minute. All right, let's have them. Pass it this way. Everybody get it right?
No.
Anybody get it right?
Sure.
One correct one. Another correct one. Better than that. Two people. Ay, ay, ay. All right, so let's look at this. So I'm going to create a string that contains all my operators.
Underscore.
Oh, thank you.
That'd be bad.
And then I'm going to return s dot index of c not equal to -1. So we're going to take our string, this plus minus times divide. We're going to call index of on the char that was passed in. If that guy is some number other than -1, that means it must either be a plus, a minus, a times, or divide. So we'll return true because this statement, s.index of not equal to -1, will be true. Otherwise, if it's not found in there, if it's not a plus, a minus, a times, or a divide, it will return a -1. Therefore, this will be false. And you can even write this as a one-liner by replacing the variable with just the string. Does that make sense? So index of is the inverse of char at. It allows us to determine whether something is in a string by requesting its index rather than getting the character at a specific index. So let me go back to the previous version of that. Okay, the 2-line. So I create a string, and I store in that string the list of crap I'm looking for. Make sense? So this is another pattern. Then what do? Well, here I can even make this a little more verbose, and I can ask questions. If s.index of c is equivalent to -1, that is, if I did not find it, return false. Else, I must have found it. Return true. That's just the more verbose way of saying the same thing. I'm being pretty redundant there, asking the question multiple times, but it'll still get the job done. So this, instead of having that big or statement, is the character plus, or is the character minus, or is the character times, or is the character divide. Make sense? But the quick and dirty solution looks like that. All right, questions on that? And notice we can do something pretty similar. Let's say that we want to write static Boolean is val to determine if a char is a val. Well, we can say string s is equal to a-e-i-o-u, a-e-i-o-u. So all the vowels upper and lower case, and then return s dot index of c not equal to -1. This guy will return true if whatever character I passed it is a vowel, and false otherwise. That make sense? So exact same pattern, just searching a different set of characters. That's the upper and lower case vowels. You do the same thing with numbers. You can do, is something a digit? Have the string 0 through 9. All right. Questions on that? All right. Let me show you something else. Let's go back to our So kind of a complex expression thing again here. We'll see this guy still works. 638. Now, right now, to collect all of our individual numbers, we wrote this parser thing down here that builds up a number inside of curnum and all that crap, right? Now, I'm going to introduce you to a couple of methods. First, I'm going to introduce you to a new class. So we have a class called the String Tokenizer. It's its own class. This guy actually lives in java.util. same place that the random class lives. The constructor for this guy takes a string as a parameter, representing the delimiters. There's also a second constructor that takes two parameters, the string delims as well as a Boolean as to whether or not it should return the delimiters. All right, so, and the two methods that we're going to use in here is has more tokens. Actually, this is going to be a method that returns a Boolean called has more tokens, takes no parameters. This guy returns true if there are more tokens in the tokenizer and false otherwise. And then we're also going to have another method that returns a string called next token. Returns the next token from the tokenizer as a string, removing that token from the tokenizer. Make sense? Well, this one requires a little bit more explanation, so I won't give you a quiz involving this one right now. I'm going to demonstrate it. All right, so I'm actually going to do this all inside main here, so I'm just going to comment out that little print statement so we won't be calling process expression anymore. What I'm going to do is I'm going to create a string tokenizer. I'll call it ST. This guy's going to be a new string tokenizer that takes in, no, hold on a second. I partially lied to you. There's two constructors. The first one has to take in the string you want to tokenize as well as the delimiters. The second one also takes in the string you want to tokenize as well as the delimiters and whether or not you want to include the delimiters in the tokens. So I forgot to give it the source string. So I'm going to create a new string tokenizer around S, the string up here, and I want to tokenize it on plus, minus, times, divide, all those delimiters. All right. So as you see right now, it's unhappy with me because it doesn't know about string tokenizer. So I'm going to import java.util string tokenizer. So I've got that guy up there. Now I'm going to create a little while loop while st dot has more tokens. So as long as there are more tokens inside my tokenizer, let's just do a system.out.println st dot next token. So there's us using those two methods. So the instance method has more tokens. And we know it's an instance method. Why? Because it does not have static at the method definition right here. No static. So that's an instance method. So we call it with an instance of the class in which it was defined, which is the string tokenizer class. and we have an instance right here. So I'm going to say ST has more tokens. So while that's true, while there's more tokens inside that tokenizer, let's get the next token and print it out. The important thing to remember here is that when I get the next token, I permanently remove it from the tokenizer. So I can't call st.nextToken 2 times in a row and get the same token. If I need that token more than once, I need to store it somewhere. All right, so we'll run this real quick and we'll see that we get 123, 2, 5, 18, 4, and 2. So we retrieve all the tokens from that guy minus the delimiters. Okay, so this kind of accomplishes the same thing we were doing before by building up kernum. So a nice, quick, easy way of doing that. Similarly, I can call the second version of this constructor, the one that takes a Boolean as a parameter, that says whether or not you want to also have it return the delimiters as tokens. So now what this guy will give me, since I passed it a true, it'll give me a 123, then a divide, then a 2, then a multiply, then a 5, then a plus, then an 18, then a minus, then a 4, then a times, then a 2. That make sense? Okay, so do we see how this string tokenizer tool works? So this is our demonstration of it. Here's a string. We build a tokenizer around that string, and what do we do with it? Well, we're just looping through all the tokens right now, and we can do whatever we want with those tokens. So any questions on how that works? So for homework, using that example for String Tokenizer and all this code that currently works, rewrite process expression in terms of the tokenizer or using a String Tokenizer. It should get simpler because now you don't have to build up kernum. Now you should be able to grab tokens. Make sense what I'm asking you to do? And I'll give you all this code as a starting point. All right, and that is due on Thursday. See everybody then.